Good morning, Pre-Cal. You know, I thought that we could begin today's lesson with a little joke. Now, I'm going to have to give credit where credit is due. I didn't come up with this one, but I have a student that will almost write a dad joke on every single test that they do. And this is the best one they're all great, by the way. And I don't want to mention names for, just in case privacy and all that other stuff, but you know who you are if you're watching this video. And I thank you for bringing a little bit of joy into my day with each and every joke you give me. But this is the best one that I thought they told. Here we go. What did the drummer name his twin daughters? And a 1 and a 2. Isn't that great? I think so. All right, it's going to be a good day. Let's do some math. Unit 9, notes day 4, polynomial and synthetic division, complex numbers, etc., etc. Now, I viewed a YouTube video on how to do all this stuff a little bit earlier, so I think I should be able to tell you how to do it. Kidding. I've been doing this for a while, but hey, you know what? There are some good YouTube videos out there. All right, divide using long division. Now, long division is the more cumbersome. It just requires a little bit more attention and focus. Now, here's the way that you set these problems up. You want to take, in most cases, probably in this class, you want to take the binomial 2x plus 3. Set it here, and then when we're doing long division, you want to set up your little division house. And then here's what you need to make sure of. Notice they have given us 3 terms. They have given us 1, 2, 3 terms. Out of those 3 terms, you always want to start with the term that has the largest exponent. So we're going to start with 4x cubed. And then from there, we want to go in descending order, and you do not want to skip terms. So 4x cubed minus 6x squared. Now watch this. Plus 0x. It did not provide us with a singular x variable with an exponent of 1. So we need to account for that. We have 0 of them. Do not put x because that would imply 1. You need to put 0x and then end with plus 6. Let me double check, make sure I did this correctly. 4x cubed minus 6x squared plus 0x positive 6. Okay, great. So this is your setup. Now you want to use long polynomial division if your variable has a number in front of it other than 1. That's where long polynomial division comes a little bit more handy than synthetic. All right, here's how I like to begin these. I take whatever the first term is inside my division symbol, and I divide it by the first term of the factor. 4 divided by 2 is 2. X cubed divided by x is x squared. So I want to take this result and write it here. Now, whatever I have just written here, I want to multiply it by these 2 numbers. So 2x squared times 2x is 4x cubed. And then 2x squared times 3 is 6x squared. Now repeat this. Underline, wrap, negative. Now, what we would have to do is then distribute this negative throughout the parentheses, and it's going to flip all the signs. So this was a positive 4x cubed. Now that once we distribute, it becomes negative. Once we distribute this negative to the positive 6x squared, it becomes negative. And I'm going to go ahead and change that to a positive just to avoid confusion. If you're doing it correctly, these first 2 terms should cancel, and they do. And then we're going to combine negative 6x squared plus negative 6x squared is minus 12x squared. And then whatever we have left over, bring that down. I'm just going to bring down the 0x just to avoid the confusion. Now we're going to repeat the process. This is our first term, so begin with that. Divide it by the first term of our factor. Negative 12 divided by 2 is negative 6 and x squared divided by x is x. So we're going to take that result and write it here. And now we're going to take that and multiply it by these two numbers. Negative 6x times 2x. Negative 6x times 3. Underline, wrap, negative. If we then distributed that negative throughout the parentheses, it would flip all of the signs. I'll change that to now positive because I've distributed the negative. These cancel. 0x plus 18x. Let's bring down its neighbor. That's a positive 6. Let's start over. First term divided by first term of the factor. 18 divided by 2 is 9, and x over x cancel one another out. That's a positive 9, so up here, right, plus 9. And now take what we have just written, multiply it by these two numbers. 9 times 2x. 9 times 3, that is positive 27. Underline, wrap, negative. If we distribute that negative throughout the parentheses, that's now negative. That's now negative. Change that to a positive, meaning we have already taken care of distributing the negative. These two cancel. 6, positive 6 plus negative 27, would that be negative 21? Now notice that we have nothing left to bring down. We have reached the end of this problem. We have a remainder of negative 21. And here's how you write anytime you have a remainder. Just take minus 21 over the factor that we started with, 2x plus 3. And this is the answer. Now, for example B, they say divide using long division. But I'm not going to use long division here because long division is long. I prefer not to use it if I don't have to. And I really don't care which method you use. As long as you know how to do them both. I don't care which one you use. What do you notice? Okay, so let's just go ahead and start setting this up. Now, since I'm going to use synthetic division, I want to take whatever factor it has given us, the binomial, set it equal to 0, and then solve. X equals 2. So with the previous example, we did this divided by 2x plus 3. With this example, we want to do this divided by 2. So whatever the factor is, set it equal to 0 and solve, and that's what you want to divide by. Now, I like to set these up as follows, an upside down division symbol. I'm going to take that 2, put it here, and then I'm going to take this polynomial and plug it in. Take note of the largest term here. And then go in descending order and make sure they didn't leave any terms out. Okay, did I write it down correctly? Looks good. Okay, now here's your first step when setting up the problem with synthetic division. Whatever, reminder, there's several ways of doing these. This is the way I do it. Feel free to follow this example if you'd like to. This part, though, is ironclad. You want to stick with this. Whatever that first number is, in this case, it's a 6. Bring it down, don't change it. Now, whatever we drop down, we are going to multiply with that number there. 6 times 2 is 12. Write the result just underneath the next term. And now we're going to do whatever these signs tell us to do. This is a minus 19 or negative 19. This is a positive 12. So negative 19 combined with positive 12, that result would be negative 7. I have now dropped down to negative 7. Let's multiply. 2 times negative 7 is negative 14. Now let's combine. 16 minus 14 is 2. Now let's multiply. 2 times 2 is 4. Now notice these numbers are going to cancel out. We do not have a remainder. One last thing we have to do. We have to take into account our variables. X cubed becomes x squared. X squared becomes x, and x to the first is no longer a variable. Just notice the exponents decreased by 1 using synthetic division. And this is our answer. Our answer is 6x squared minus 7x. Oops, that's positive 2. So plus 2. Isn't synthetic division better? Now for example 2, they say now do example 1b using synthetic division. We did that. What they wanted you to do is take the same problem, solve it 2 different ways, and realize that you're going to get the same answer. I just saved this some time because if we did it using long division, it would have taken a lot longer. All right, something to remember when dividing. You may not skip any terms if you wanted to divide. This one right here is a bit of a beast, isn't it? So a large polynomial there. So let's use synthetic division to save ourselves a little bit of time. Let's take the factor that we're dividing by, x plus 1. Set it equal to 0 and solve for x. So that's what we want to divide by. -1. Let's see, what is the highest term? Looks like x to the 5th. So let's go in descending order from there. I need a 4th, minus 2x to the 4th. I need a cube plus 3x squared. I need an x. Oh, look at that. I'm glad I was talking out loud because I just caught myself making a mistake. Let me get my correction tape. I said I need a cube, and they didn't give us the cube, did they? We have a 5th power, we have a 4th power. They did not provide us with a 3rd power. So we need to do 0x cubed. Now, I need a squared term after that, plus 3x squared. I need an x term, minus 2x, and then I need my constant, plus 5. Now let me double check one more time, make sure I did that right. Good. And now we are ready to begin solving. So whatever the coefficient is of the leading term, drop it down. In this case, it's 1. And now we multiply -1 times 1. Now we combine -2 plus -1. Now we multiply -1 times -3. Combine 0 plus 3. Multiply -1 times 3. Combine 3 minus 3. Multiply 0 times -1. Combine -2 plus 0. Multiply -1 times -2 is +2. We have a remainder of 7. I just like to section that off to not get confused. So we have a remainder of 7 here. Now I'm going to bring down my variables and decrease the exponent by 1. That x disappears. We have a remainder of 7, so plus 7 over, remember, we're going to use the factor that it gave us, x plus 1. So let me clean this up just a bit and give you the final answer. Where's my plan? There it is. All right, begin with x to the 4th. That's a positive 3x squared, so plus 3x squared. 0x, don't need it. Minus 2, and then plus a remainder. Boop. That's your answer. Example 3, given that x plus 2 and x minus 3 are factors, use synthetic division to find the rest of the factors of the given polynomial. Then write the polynomial in factored form. So we can take either of these factors and set them equal to 0 and solve. It doesn't matter. So why not just use the first one they give us? Set it equal to 0. So we will be dividing by -2 in this problem. Looks like the highest term that they give us is a cube. So I'm going to need a square after that. Then variable x. Then the constant. Did I write it down correctly? We look good. Let's get going. Bring the first number down. Don't change it. Multiply. Combine. Multiply. Combine. Multiply. No remainder. Now we're going to bring down our variables, and remember, they decrease by 1 exponent. Now that is our answer, but wait. Remember, they said use these factors to find the rest of the factors. So what that means is this can factor further. So we need to do that. Let's multiply the first term times the last term, the numbers themselves, not the variables. So 2 times 3. 6. Now we need the factors of 6 that add to get 7. Same signs, both negative. And now I can create a grouping problem beginning with the first term, 2x squared. Now substitute your factors and give them an x. And then end with plus 3. Okay, out of this group, looks like we could factor out a x, and that would leave us with 2x minus 1. Out of this group, looks like we could factor out a -3, which would leave us with 2x minus 1 again. Let's combine our outside terms, x minus 3, and one set of the matching parentheses. Okay, so we have factored that trinomial. We have the factors x minus 3, 2x minus 1, and don't forget the other one, x plus 2. And now I think we've answered or did the problem. Then write the polynomial in factored form. Done. Okay, example 4. Evaluate the function using synthetic division and then try plugging it in. So they want us to use 4 here. They're telling us use 4. Looks like the highest term it gives us is x cubed. So we must have an x squared, which they did not give us. And then an x. And then the constant. Let's get going. Drop down the first coefficient. 1. Multiply. Combine. Multiply. Combine. And then multiply 18 times 4. What is 18 times 4? Looks like 72. And now combine. Okay, let's write our variables. Decrease 1 exponent. So x cubed is now x squared. X squared is now x. Don't need an x there. And remember, this is our remainder. If it gave us the 0 of 4, that means in factored form, it must have been x minus 4. Okay, so we solved, we did what it told us to do. Now we're going to take 4 and simply plug it into the function. Let's do that and see what happens. So instead of, you know what I'm going to do? I'm just going to do this for right now. Now, here's what I did. I rewrote this function x cubed plus tx plus 5, but instead of x's, I put parentheses, and in those parentheses, we want to plug in a 4. And then order of operations, parentheses first, but there's nothing to simplify in the parentheses. So let's do our exponent. 4 cubed is 64. Now we can take care of this multiplication here. 2 times 4 is 8. Don't forget we're adding 5 to that. And if you were to add all this together, we would get 77. The exact same number as our remainder. Factor theorem. If f of 3 is equal to 0, then you know it is a factor. You know x minus 3 is a factor of the polynomial. Cool. Example 5. Find a polynomial equation for a polynomial with the given zeros. If we know these are zeros, those are x-intercepts, this is what they would look like in factored form. In factored form, keep the number, but just reverse the sign. What are the x-intercepts? Well, these are what they are. Zeros is one way of saying x-intercept. So we have an x-intercept of -7, 3, and -4. And then example 6, a little bit of a review from what we did last class. Find a polynomial equation of least degree for a polynomial with the given zeros and multiplicity. Y equals. So we have an x at, I'm sorry, the zeros are 0. So in factored form, that's simply x. We have an x-intercept of -2. In factored form, that's x plus 2. That 0 has a multiplicity of 2, so give that factor an exponent of 2. We have a 0 at 3. In factored form, that's x minus 3. It has a multiplicity of 3, so that means give this factor an exponent of 3. And we are done. Have a good day.